Okay, welcome to lesson 8 of paper 1, topic 2, electricity. And in this lesson we'll be looking at the two power equations. So if we take a simple circuit, so we'll take a cell, we'll have an ammeter, so we can measure how many amps are flowing, the current. We put something in like a light bulb and we complete the circuit. Then we go to measure the voltage, so we put a voltmeter around the thing we want to measure and we measure the volts. Our question that we want to answer is, how many joules of energy a second is the light bulb giving off? And the answer is really easy. If we measured the current, say it was 2 and the voltage was 5 volts, then to calculate the power of the circuit, it is just purely current times voltage. So that's our first equation, current times voltage. And so in this case we'd do 2 times 5 and we'd say here the power was 2 times 5, 10. Now we need a unit. A guy called James Watt figured all of this out, so the unit is watts. Like so. And if we don't want to write the word watts, we can just write a capital W on the end. Current, if you remember, is measured in amps, and voltage is measured in volts. Volts, like that. Okay, now this is important, so we'll put this in a square rectangle like so. We'll get the highlighter on it, key point, so we'll put a bit of pink on this. Okay, now algebraically we can write it out as this: P is equal to IV, PIV. And as a triangle, it will go like this. Power is current times voltage. And if we want to rearrange it, remember we cover up the one we want. So if we wanted the current, we can cover up the current and we say what we see: power divided by voltage. So we write power divided by voltage. What if we wanted the voltage instead? So let's put this back as it was, put that bar there we go. So let's try again. Let's do this time, we've been given the current, we've been given the power, we've got to find the voltage. So we write down what we want, V, we cover up the one we want, we say what we see: power over current. So I divide them again, power divided by current. And I put the numbers in and I get the marks and life goes on. Okay, so that was a bit over enthusiastic. I think it's because this is too large. There we go. Let's try that. Woohoo. Okay, so that's our question. Now let's have a look at what kind of exam questions have been set in the past. So sometimes you do get given the answer in the like the equation, like it was here. You get it in the paper, but you are expected to memorize it in case you're not given it. So let's have a look. The lamp is connected to a 24 volt power supply. The current, I'll make this a bit smaller. The current is 1.5 amps. Calculate the power. Okay, so we write down power equals IV. And we're going to times them together. So we've got 1.5 times 24. And that equals, now if you haven't got a calculator, and you should have, I haven't, so I'm going to do it manually. So if I do 1.5 times 24, well, what have I got? I've got one lot of 24 and I've got half of 24, which is 12. So 24 plus 12 is 36 watts. And they've already written watts on the end, so you don't get a mark for it. So that was a 2-mark question. You always show you're working out here. So even if you make a mistake, you will still get 1 mark. So if you write that down, and then like me, you tried to do it in your head, but this time you made a mistake, you will still get the mark for working out. So always show you're working. Let's try the next one. Now this one's a little bit different. Let's have a look. We've got a power output of 2.53 kilowatts. And we've got a potential difference, slightly different word here, of 230 volts. So it's the same question, but a little bit different. The first thing they want to do is they're giving you it in a different unit. They're giving you it in kilowatts. So a kilo, as we remember from a kilometre or a kilogram, means 1,000. So I times 2.53 by 1,000. 2.53, I times it by 1,000, and that will convert that number to 2,530 watts. So there's my power. Next, they've used the word potential difference, and now that is another word for voltage. They're the same meaning, and it's 230 volts. Now, they want me to find the current. So my safest bet is to use my triangle. So how I would do this is I would write my triangle. I would memorize the triangles before I go into the exam, and then I'd write P, I, V. I'd cover up the one I want. So in this case, I want current, like so, and I'd write out what I'm going to do. That immediately will get you a mark. Power divided by voltage. Now I'm going to put my numbers in. So 2,530 watts divided by 230 volts. Now I'm frantically looking for my phone because I'm not that clever. So I've got my calculator out, press cancel, right. So 2,530 divided by 230 gives me an answer of 11 amps. And that's how you solve that one. That one would be a good one to get. That's 3 marks, which is about 4% of the whole exam. So well worth learning these things. Now, I said there was 2 equations. The second equation comes up now and again. It's a bit trickier to spot, and it's this. I'll just give you it straight. Power is equal to current squared times resistance. Okay, put it in a box. It's a really important one. It usually comes up more on the higher paper, occasionally, and it sometimes comes up on the multi-mark one, like a 5-mark question where you have to get from one type of equation to another. So it really is kind of pushing it a bit. Algebraically, it's written as P is equal to I squared R. And where you'd want to use it is if we go back to our circuit. Let's stick with 2 amps. We've got our bulb, and we've got our voltmeter, but then we're not interested in the voltmeter this time. But we know that the resistance of the bulb, for example, is 10 ohms. So we can still find the power inside the circuit. So we would do 2 squared, there's the current, times 10 ohms. So 2 amps squared times 10 ohms. And so that would give me an answer of 4 times 10, a total power output of 40 watts. Now there is another way of writing watts out, because if you think about it, a watt is also how much energy per second. And if you remember from topic 1, lesson 1, we learnt about the power equation. It was probably lesson 4 or 5, the power equation. And we learned that power is how many joules per second. And it's energy over time. And they're the same thing. If you use the word power, they're the same thing. So another way of writing watts, you can actually write it out as joules per second. And it helps you remember what power actually is. It's how many joules of energy every second you're burning off. Okay, so if you're doing a low power activity, or you've got a low power bulb, not a lot of energy every second. High power activity, I don't know, sprinting like crazy. High power bulb, really bright, loads of energy a second. So that's what those mean. Now, if at this point you are happy with what I've said, you can stop. If, however, you are really thinking about kind of going on to A-level and you want this little bit extra, carry on watching for a second. Okay, there's probably only one of you left now. So, a quick aside. Where did this P equals IV come from? Okay, so if we unpack this, current is how many coulombs of charge per second. And hopefully you've watched my lesson, I think it's lesson 2, on what actually electricity is. And we saw that electricity, current, is the flow of charge. And 1 amp is equal to 1 coulomb of charge. It's not Q, it's 1 coulomb every second. So 2 amps is 2 coulombs every second. Really easy. Okay, what about voltage? Well, we saw voltage is how many joules of energy per coulomb. Okay, I'm going to change that Q. I'm going to write it in terms of units. There you go. So I've got current is how many coulombs per second. Voltage is how many joules each coulomb is carrying. And when we times them together, let's put them together now just as their units. C over S, J over C. And look what happens. Cancel, cancel. I end up with J over S, joules per second. So I've proved that this equation is correct by breaking it down into actually what is current and what is voltage. Another thing, if you're still with me, where did P equals I squared R come from? Well, if we go back over to an old lesson on Ohm's law, we know that voltage is current times resistance. VIR, Ohm's law. Okay, none of this is news to you. Okay, so we can write the equation like that. Well, now let's write out PIV again. PIV. But this time, we're going to take the voltage and we're going to substitute in the IR. Because if I times the current and the resistance together, I naturally have calculated the voltage. There it is. So I'm going to take those values and I'm going to replace them. So let's write it out. P is equal to I. I'm not going to write V. I'm going to write IR. IR. Now if we tidy this up, I times I is I squared R. So that's where that equation actually comes from. A lot of physics equations, usually they're kind of reprocessed versions of previous equations. So it's not that they're all brand new every time. It's just that they're given to you in a slightly different packaged way. Anyhow, hope that's helped, and good luck. Take care.